think I'm going to just write stuff down. Good. Okay. Hello and welcome back to IXL Tutorials. This is Mr. Duffick, and today we will be going over IXL S11, which has to do with comparing the perimeter and area of shapes after they change size or scale. Okay, and so for this problem here, we have a basic square, right? Every side is 4, so 4 times with 4 with 4 with 4. And the question is saying that if the lengths of the sides triple in size, so 4 times 3 is 12, so each of these now becomes 12, what happens to the area of the shape compared to the old area? Okay, so in order to understand these IXL problems, there's only two things you really need to know. And the first has to do with its perimeter, and the second has to do with the area. So let's start by calculating the perimeter here, just so I can illustrate my point. The perimeter of the shape is going to be adding all the sides together, right? So 4 plus 4 plus 4 plus 4, or just 4 times 4, right? And that's going to equal 16. And I'll say that's the perimeter of our first square. Now the second square, I'll say perimeter of the second square. If we're tripling our lengths here, the side lengths of our square, that means the perimeter is also going to triple. So we don't have to actually count things out. If the perimeter of our first square was 16 and we triple everything, that means the perimeter is also going to triple. So 16 times 3 is going to be 48. So we go from 16 inches to 48 inches. Okay. Now that's perimeter. Perimeter is easy. Perimeter will get larger or smaller based off of how larger or smaller these side lengths change. So that's easy. Now area is a different story. With area, we are going to calculate the area of the first shape. So we'll do 4 times 4 is 16. Okay, 16 inches squared. Okay. Now with area, we're not just going to multiply this by 3. We're going to multiply by 3 squared. Okay, you're going to square all of the factors you multiply by when it comes to area. So instead of doing just 16 times 3, we are going to do 16 times 3 times 3, or 16 times 9. So we'll do A2 equals 16 by 9. And so the area of our new shape is going to be 144 inches squared. Okay, it's kind of a shortcut. You could do the math, but it's kind of a shortcut. And so that's the point I'm trying to illustrate for this problem, because this problem is asking for what happens to the area. Well, since we know the side lengths are getting 3 times as large, that means the area is going to be get 3 times as large, or 9 times as large. So that's going to be the fourth option down there, which is 9. Okay, so now this one. If both dimensions are tripled, so they triple the dimensions, what happens to the perimeter of the shape? Okay, now perimeter is simple. Perimeter will also triple in size. So we go over here and we see the ratio of the new perimeter to the old one is going to be 3 to 1. That just means it gets triple, or 3 times as large there. Okay. Next, the radius. So the dimensions are doubled. Which of the following statements about the area will be true? Okay. So if the dimensions are doubled here, if we were trying to find perimeter, that would just mean that it would double as well. But since we're doing area, it's going to be 2 times 2, or 2 squared, times as large. So that would be 4. So the area is going to get 4 times as large because the radius is only doubling. So we'll go down to 4. Good. Another circle one. If the radius is tripled, what happens to the circumference? Okay, so the dimensions again are being tripled, and this time it's circumference or perimeter, right? Which is simple. If the dimensions are tripled, that means the circumference is also tripled. So we'll go down here. The ratio of the new circumference to the old is 3. So it gets tripled. Good. Another circle one. If it's quadruple, then what happens to the circumference? Well, it gets 4 times as large. Right, here we go. The height is quadrupled, so it gets 4 times as large. Which of the following statements about the area will be true? Well, remember the area is doing 4 by 4. But you also might want to notice that it's just going to do the height, right? It's not doing the base. So what we'll do is just compare what happens. So if we're doing area, the area of our first shape is going to be 3 times 6, which is 18 inches squared. Okay. Then the area of our second shape, so that's just going to be when we quadruple the height. So if we quadruple the height, that's just multiplying 6 by 4, so that ends up as 24 as a height instead. So the area is going to be base times height, 3 times 24. 3 times 24 is going to be 72 inches squared. Oof. Okay. So how do we get from 18 to 72? What do we have to multiply? Well, is it 4 times? 18 times 4 is 72. Well, yeah, okay. So the new area will be 4 times the old area then. Good. Okay, so now we have a triangle. The height is halved and the base is tripled. Which of the following statements about the area is going to be true then? Okay. And so this one's going to require a little bit more work, but it's the same process as last time. So all I'm going to do is find the area of our first triangle. So remember, triangle is base times height over 2, or 1/2 base times height. So the base of the entire triangle looks like it's 5 meters times the height is 2 meters all over 2. So that's just going to equal 5. Okay. Now for our second area, it says the height is halved, so 2 becomes 1, and the base is tripled, so 5 becomes 15. What happens to the area? Okay, so base is now 15 times our height, which is now 1 over 2. So 15 meters times 1 meter is just 15 meters squared. And then 15 over 2, 7.5 meters squared. Okay, so then how do we get from 5 to 7.5? Okay, well, is that a factor of 12? No. Is it 1.5 times? Yeah, I think so, right? If you're multiplying 5 times 1.5, you're going to end up with 7.5. Is it a fourth as big as previously? No, because it's getting bigger, right? Is it 3.5 times? No, it is not. So it is going to be 1.5 times as large. Good. Radius is tripled. What happens to the area? Okay, well, I'm sorry, quadrupled. So again, since we're dealing with area, it's going to be 4 squared. It's going to be larger by 4 squared, which is 16. So it's going to be 16 times as large. Okay, and from there, it's pretty much the same type of problems. The height is halved and the base is quadrupled. Then you just compare the two areas. Okay, what will happen to the area if they're both halved? Okay, etc., etc. So I'll stop the video here, but I will end with this. Know the rule that the perimeter and the circumference are going to increase with the dimensions. They're going to increase by the same rate, assuming everything's consistent. And the area is going to increase by square factor of how much it's increasing by.